In this video, I'm just going to show you how to create a parabola. In this case, I've just picked some random numbers. The width is 36. The focus distance from the origin is 10. And it's going to look something like this. The parabola when we're done. Something like that. So I'm going to show you how to do that right now. So we've got the directrix, the origin and the focus. They have to be the same dimension. The origin here, we're going to put it at 0, 0, 0, 0, so that we can use the simplest form of the equation. It's not an it's not a this isn't designed to show you the formula where to place it in space, or in the direction, but just how to create a parabola with the focus distance. So the first step we're going to do is divide this directrix. How let's see, 36, that's going to be 18, about 4 bays, just to make sure it's a very coarse. If you were framing, that'd be close enough. So draw, tick mark. I think I already got 4 and 10, so I should just break that up into 4 sections. So let's go to the first one. So what we need to do is we need a distance between here and the point on the parabola. And the point on the parabola down to here should be the same. So we're looking for a isosceles triangle. So we're going to go where the midpoint of that, we need a perpendicular bisector. So do it this way. If it was with the framing square, it would just come out there and then trim this line to the x coordinate, and there you go. So you will just run this up till they intersect. There you have the first one. Change color to the next one. And then V for where that red line intersects the x-axis. We're going to draw another line. It's going to be perpendicular from there. Trim it to the x coordinate. There we go. And then let's do another one to show you in case there's in the event that you didn't have a framing square. You could snap this line across there and then do an arc. How about a negative 100 right there, and then do the same mark from here, positive 100, like that. Where those intersects, the center of that, you can run it in there like that, and that's going to give you an exact, let's delete, as long as those arcs are the same distance. So 24.1299, 24.1299. It could be, it could be smaller or bigger even, doesn't matter. Delete, and trim that to there. And same thing here. So we got to do, let's pick a different color, purple. V, enter, V, F4, where that purple line intersects the x-axis. J, A, enter. And where those two trim to each other, there's your last point. So in this program, I could do C, which is a curve. It'll give me a pretty smooth curve. Enter, and then I'll have my parabola that way. So I could delete all this, right like that. Delete, and I can check those points. Let's see, draw point mark. I can check them with some math. Doesn't really matter. Let's go back. Boom, boom, boom. All I need to do is check one right here to make sure that the parabola is accurate. So at the x distance of 18, the y value should be 8.1. So let's check the math. So the formula for that is t. So x squared is equal to 4py. That's the formula in the simplest form. Like I said, the origin's at 0 and it's facing up. No, that's it, simplest one. So to rearrange that, find out what y is, we're going to go x, missed something there, didn't I? X squared. So tx squared divided by 4p equals y. And let's plug those numbers in. Tools, calculator, and then we have x squared, which is 18 squared, divided by, open parenthesis, 4 times p, which is 10. Think of p, kind of reminds me of the threads on a pitch of a thread or something. So compute, you end up with 8.1. So we know that that's an accurate representation. Also, you could come in here with this ray was, let's run this, extend it. Control Z, let's do this. Control R, V, H, enter. So this angle, the ray coming in here would reflect off of this angle, so we could go like this. Control H, Control C, V. So that should be reflecting right to that point. So this angle out to MA, the reflective angle. It's just two different ways to check. F3. That those two angles are exactly the same, and it hits that focal point. That's the tangent line to the point on the parabola. And if it was a steeper parabola, you could probably hit this. I don't think it would. VJ, A, enter. Yeah, if it was longer, it would. Yeah, it's just missing it. But it would also hit another tangent point on the parabola. That's one of the principles of a parabola. And also, Control R. Let's just go backwards. If I do this video again, I'll make sure that the one of the points hits the reflective point there. But oh yeah, and then here, any one of these points to there, from there, and then H, K, those should be exactly the same too, and that's what we got. So it's definitely a good parabola. You want to check before you go, and you have to check. So the next step is we're going to take this and we're going to find out what's the formula. So I'm going to take that, tools, calculator. I should have copied it. Maybe I did. Control V. No, Control V. No, I didn't. X squared, which is 18 squared, divided by 4 times 10. And that's what I'm going to copy. Control C, compute, Control V equals. Now just Control C, paste that right here, Control V, enter. And then I can open up Excel. Go right here, Control V. So now I've got that pasted there so I can see what my numbers are. We need P, enter, which is 10. Width equals 18, so it'd be 36. That's the full width of the parabola. And the increment, let's go 100 microns. Let's make it very accurate. Would be, I think it's 1, 2 equals 1 divided by 256 is 100 microns. But it's still in inches. It's like 99 microns, something like that. And then we're going to do equals 36 divided by, that will give us 9,000 coordinates, the x coordinates to do. It just seems like a lot, but in Excel it's pretty easy. So actually it would be 92, 16 plus 1. Theoretical shed type stuff. It's the 2 sections, 3 points. So 9,216 sections, 9,217 points. So let's create the formula. So equals 36 divided by -2 will give us -18. That is the farthest point on the left, right there. So this is 0. And if we put a point there, enter, let's see what the should be. The coordinates would be -18, positive 8.1. So that's the first one we're looking at. We're going to go from left to right. There's options. You can do anything you want, but that's how we're going to do it. So the first one's -18. Then we're going to type in the formula equals -18 squared divided by open parentheses 4 times P, which is 10. Actually, no. E, 18, that's going to be relative. And then this is going to be reference locked. And then we'll come over and close that parenthesis. And that's a good one. We should end up with the 8.1, right? So now let's concatenate these two with a comma in between so we have a XY format for AutoCAD. So equals this 18, and then we want to put an and symbol, open, comma, close, and symbol, and the next one is there is enter, and we should have negative 18 comma 18.1. That's a format that AutoCAD recognizes. And then we're going to go equals negative 18 plus this, and that's going to be a locked cell, a locked reference. Enter. So if we just draw that down, basically going to get closer and closer to 0, and then once I hit 0, it'll get bigger. These are all negative. Control Z, and let's paste these down to here. Now I'm going to take this 3, Control C, and hit that, and I'm going to go E3 to E 90, 92, 17, enter, Control V, and there we go. We have negative 18, and if we go to the bottom, we should have positive 18, 18.1. So let's go back to the top, Control arrow up, and then all we got to do is double click on this, and it'll select all those all the way down to where we were just at. Oh, it doesn't do it. We need to copy it first. Right there, selects it, and then Control C, and then I can go down to the bottom, and it's selected all that. Didn't move stuff around. Let's go to the top, just double click it, and copy it, Control C. Let's open up AutoCAD, and we're just going to go ahead and type in PL right here, enter, and Control V, and that's going to create the parabola. And that's 100 micron increments in the X direction, enter. So now let's go back to show you the reason why I put those into reference cells is, let's say we had a 24-inch width and a 6-inch. Everything over here is getting updated. We'll still do the same increment, but now this is equal to 6145. So I think I'm going to go down to 6145, E 6146, enter. Right, and that's where I'm going to start. I'm going to take 46. I'm just going to delete all that. Now it's given me 12 and 6, 12 comma 6. The other one at the top should be negative 12 comma 6, right? So that's a good one. So all we got to do is copy that, Control C, open up AutoCAD, and PL, enter, Control V, and we'll draw a second parabola in there with the different formulas. All that would happen is if we didn't truncate that formula, it would going up here, and you'd have to just run a line across and trim it. But that's the advantage of being able to know how to construct a parabola and how to deconstruct it for the formula, and then use the formula to put it into Excel and paste it into AutoCAD. And that's a lot of information in under 15 minutes, but I hope it helps you in your career, and thanks for watching.